Hello everybody, we're talking about piecewise functions. Piecewise functions look like this. We have the value of the function at one point is this, but at some other time is this. So we'll have the value, say when x is less than 1, and then the value when x is greater than or equal to 1. So the way the graph looks on this function, so it's going along and we have an x value of 1. So this is where it's going to switch from one type to the other. So if I were to graph just y equals x, that would be a line going through x equals 0 and y equals 0 and something like this. So for right now I'm going to do an open circle and it's just a line going like that. And then when we get to that point, because the reason I did an open circle is so x was strictly less than 1. So it would not actually be equal to 1 if I just looked at this part right here. So now looking at this part, y is equal to 1 over x. So let's see, 1 divided by 1 would be 1. So also the value of the function at that point would be equal to, so if this is y, would also be equal to 1. So now I'll just fill it in because this one tells me that y is equal to 1 when x is equal to 1 also. And then when x is equal to 2, this would be equal to a half, and x is equal to 3 would be a third. And there it kind of curves down, and it gets closer and closer to 0 as x gets bigger. So it kind of curves down like this. Okay, so that would be a piecewise function, and you can see that how the graphs will look is it's following one pattern, then at some point it changes its pattern or continues on in a different way. So it might be that it comes out like that or curves up or whatever. This example for g of x, so this one it splits at x equals 0. So it's going along when x is less than 0, y is equal to 5. So 1, 2, 3, 4, 5. So for all these values of x, y was equal to 5. And then we hit this one, and then since it's strictly less than 0, I'm going to do an open circle. And then when x is equal to 0, then we go to this function, y is equal to 2x, which is a line going through the origin. So we're going to do a filled in circle there. So when x hits 0, it's equal to 2, right? Or equal to 0. X is equal to 0, that's equal to 0. And then it has a slope of 2, so it's going up 2 over 1, 2 over 1. So it follows this pattern from that time on. Okay, so you can see that this one actually changes value, it drops down, and we have kind of a break in the pattern that the function is taking on. So these are examples of some piecewise function. One of the most important piecewise function is the unit step function. The unit step function is kind of like a switch. And we just say u of t is equal to, so it's equal to 1, or it's equal to 0 when t is less than 0. So it's going along, it's valued at nothing, 0, so it's nothing, 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 and it hits 0, and we have open circle. And then when it gets to anything greater than 0, so greater than or equal to 0, then it turns into a 1. So it just turns on. It's like a switch. So the time when we say, like -5, -4, it's like t minus 5 seconds. So 5, 4, 3, 2, 1, 0, and then the switch gets flipped, and it turns on, and now it's equal to 1. So for all time beyond that, it would be equal to 1. So this is a very useful function and kind of defining piecewise functions because sometimes we want to turn things on at a certain time. So we can shift the time over by saying u of t minus c, right? So this kind of shifts the time over. So this when t is equal to c, right? When t is equal to c, then you get u of 0, right? So c minus c would be 0. So this would be 0 when t is less than c, and this would be 1 when t is greater than or equal to c, right? So this kind of looks like this. So we said some point when we finally get to that number c, whatever it is, then it turns on. So it's off, and then all of a sudden it's on. Okay, so that's kind of an example of using that unit step function. There is also called the unit box function, which is let's have two variables here. So we have 0 is less than or equal to a, which is strictly less than b. So this kind of, it turns on and then turns back off again, and it's u of t minus a, so that's when it's going to turn on. And it could be 0, so it could turn on at 0, minus u of t minus b. So what happens is it goes along, it's off, and then at a it turns on, and then it goes along, and then at b then it's u minus u, so it's just equal to 0 again. So it turns off, and it looks like that. So this is at b. So that's some different examples of using piecewise functions, and the unit step function is kind of one that gets used a lot. And you can say, if you want to break out a little piece of any function, you say, well, just f of t times this box function, right? U times t minus a minus u times t minus b. So this would be whatever that function f of t is, it will turn on at a and then turn off at b. So if your function was something like that, but you wanted to just look at some part of it, you could say this would be all of these numbers times 0 would just be 0, and then at this point it would be the function values times 1, which would just be the function values, right? All along those points, and then after b it would be equal to 0 again. So it would look just like this. Okay, so it's a good way to use little parts of a function if you need to.